Furthering our exploration of aromaticity, we're going to explore why pyrrole will rehybridize its lone pair from an sp3 orbital into a p orbital so that it can take advantage of the fact that p orbitals resonate with other p orbitals. These are p orbitals being used for pi bonds. They can now resonate with this p orbital with a lone pair. Bring the total number of pi electrons, and I will count starting over here, 2, 4, and after rehybridization, p orbital electrons are counted as pi electrons, and there's 2 more for 6. 6 pi electrons is the required amount for aromaticity of pyrrole. So, if an atom with a lone pair in a hybrid orbital is required to resonate with pi electrons to get to the number 4n plus 2 pi electrons, then it will rehybridize to get the lone pair into a p orbital. Hopefully the following animation will let you visualize the transition from pyrrole with this hybridization to pyrrole with the sp2 hybridization. And I would like to point out, midway through the animation, we're going to be here, and that will be the way pyrrole looks 99.999% of the time, because it's when it looks like this that it is aromatic. On the outsides it is not aromatic, so there's no need to be out there. These lone pairs, unable to resonate in an sp3 hybrid, would rather be a lone pair in a p orbital resonating with all of these pi electrons. So before we begin the animation, here's the molecule that's going to start moving. Here is the sp3 hybrid, which must rehybridize to a p orbital here. And let the animation begin. We are at the halfway point. The molecule is going to spend almost all of its time like this, with all 6 pi electrons freely resonating in a circle. Just a brief reminder, half the time electrons in a p orbital will spend time in the bottom lobe, the other half in the top lobe. This brings to a closing animation. We've arrived at this hybridized form here, and the molecule is going to spend almost no time like this, spending 100% of its time like this. P orbitals resonating with each other fully in a circle, top and bottom. One final exercise down here. Let's look at these 3 molecules and answer the question, which lone pairs, if any, need be used to achieve aromaticity? This nitrogen here is already participating in a pi bond inside the ring, so it cannot use this lone pair. This oxygen is clearly going to need to resonate, so one of those lone pairs must be rehybridized. Leave the other one in a hybrid orbital. It will be an sp2. My answers for the lone pairs that are needed will be red lone pairs here. In lysergic acid, the aromatic portion is the bottom ring system, and nitrogen as in pyrrole up here. Nitrogen needs to rehybridize the lone pair. In this case, to get to 10 pi electrons, resonating also with the benzene to the left. Benzene provides 6 pi electrons. This portion provides 4 more. This nitrogen's already resonating, so you cannot use this lone pair. You're going to require this one, and this one to get up to 10 pi electrons. Counting the 10 pi electrons, we have the lone pair for 2, lone pair for 2 more up to 4, pi bond 6, lone pair 8, pi bond 10. I hope you found this video on aromaticity and rehybridization to be useful.